Okay, gang, let's talk about composition of functions. And this is in the textbook in section 5.1. And what I have up here on the board is the definition step and the main thing to keep in mind for our function compositions. F composed with g of x, this little open circle, it's not an O, it's not fog of x, but a little composition symbol. This means that if you take function f of x and function g of x and you form a new function, the composition of the two, f composed with g of x, what that means by definition is f of g of x. You want to make sure you have this in your notebooks and that you really memorize it and use it all the time. F composed with g of x is f of g of x, is how that would be pronounced in language. And let's take a look at a kind of a function machine picture of what's going on here. If you ever think of a function as a input-output machine with x flying in the top, and this is supposed to be f composed with g of x, what the definition is saying is that what should come out here is f of g of x. And let's explain what's going on inside the function machine to make this occur. Really all a composition is it's two functions hooked up in series to make a new function. So inside this black box there are two functions inside here, f and g. And the most confusing thing about the way compositions work is in f composed with g, it's actually g that's the first function that works on the input, and f is the second one. You can see that here too. X gets run through the g function, and then the output of g of x goes through the f function. So it's the two functions hooked up in series, but g comes before f in f composed with g. So inside here, the x drops into the g function and it's processed through here. And so of course what comes out is g of x. And then the output from g, the g of x, is what is the input into the second function f. And of course what happens there is that f processes g of x and you get f of g of x out here, and that's what's coming out of the composition in the end. Let's take a look at an example. And let's use f of x, the quadratic function x squared minus 1. I hope by now you can all just picture that as a basic parabola shifted down 1 unit on the coordinate plane. And let's look at g of x. Let's pick one of our toolkit functions, the basic rational function 1 over x. Okay, so now forming part A, f composed with g of x. Almost always in a problem involving composition, the first thing you do is the definition. So you see f composed with g of x and immediately write f of g of x. And then, because g is the first thing that happens in the composition, you always work from the inside out. So looking at an expression in this form, I'm always going to look at what's happening inside the parentheses first. What's g of x? G of x is 1 over x. So I'll just substitute the formula 1 over x. And then this should remind you of homework earlier in the course. F of 1 over x is just what the f function does if you input the formula 1 over x. So f is the function that takes any input, squares it, and subtracts 1. So here it's going to take this input and square it and subtract 1. I suppose I could write this simplified in this form, and that is the new function that we form by composing f and g. That's f composed with g of x. It's interesting to, at the same time, look at what happens when we compose in the other direction. So b, let's look at g composed with f of x, and let's see, by definition that's g of f of x. And let me check my camera monitor to see if I'm slipping off the page here. No, you can still see that. I thought I might be writing out this way. Okay, so we're talking about g of, and now I want to work from the inside out, so I look at f first. F is x squared minus 1. G of that formula is input that formula into a function that takes the reciprocal of whatever you give it. So it'll even give you the reciprocal of this expression. And that is a formula for g composed with f of x. One thing that's interesting to note about compositions, composition is not commutative. F composed with g of x is not necessarily the same thing as g composed with f of x. Let's see, if you look at a particular input here, f composed with g of 2, for instance, would be 1/4 minus 1, that would be negative 3/4. And g composed with f of 2 would be 1 over 1/3, a different output. F composed with g of 1 is 1 over 1, is 1 minus 1 is 0. So f composed with g of 1 is 0, and g composed with f of 1, 1 over 1 squared, 1 over 0 is undefined. So compositions are not the same one direction as the other necessarily. Now let me turn down the lights and take a quick